So first thing we need to remember is that fundamental theorem of calculus we talked about yesterday. If we take the definite integral from a to b of little f of x dx, we get the antiderivative of f of x, which we represent with the capital F, and then we evaluate that from a to b, which means that we have to do antiderivative of f of b minus the antiderivative of f of a. So for our first problem, we know antiderivative of sine of x. We don't have to do anything to change this, no u substitution, no rewriting. We can just do the antiderivative and then evaluate it using this fundamental theorem of calculus. So what is the antiderivative of sine? Antiderivative of sine? Negative cosine. Right? So we're evaluating that from 0 to pi, which means we're going to do negative cosine of pi, or opposite cosine of pi, minus negative or plus cosine of 0. So we can think about those on the unit circle. Cosine of pi would be negative 1, but there's a negative on front, so that's going to give us positive 1. And then cosine of 0 is 1, so 1 plus 1. The area of this one actually comes out to 2, which might be kind of a surprise. You think about area under sine of x. You wouldn't necessarily expect that to come out to a nice value. But if we look at sine of x, this would be like 1 full period to 2 pi. We're finding area under sine of x from 0 to pi. So this region right in here actually has an area of 2.